Hello and welcome to Chapter 5. Today we're going to discuss measurement. A measurement is a unit of distance, weight, or volume. So for example, if I have 3 inches, that means I have this unit of an inch, which is agreed upon by everybody. It's, say, this long. If I have 3 inches, that means I have 3 of those distances, end to end, for a total of 3 inches. When I measure something, the precision and accuracy with which I measure it is important. However, in order to understand precision and accuracy, we first must need to understand significant digits. So let's take a look at the rules for significant digits. These are the rules for significant digits. All non-zero digits are significant. For example, 1, 3, 8, those are significant digits. Zeros are significant when it appears between significant digits. So like in the number 102, the 0 is significant because the 1 and the 2 are significant. So in this case, 102 has 3 significant digits. If it's at the right end of a decimal number, so for example 3.0, this has 2 significant digits because the 3 is significant, and the 0 here is at the right end of this decimal number. Or if it is marked with an overbar, so for example 270, the 0 is not between significant digits and it's not at the end of a decimal, so to make it significant I would put a bar over top of it. So we have here now 3 significant digits because of that overbar, making the 0 significant. Zeros are not significant when it's at the right end of a whole number, so that 270 without the overbar, just like this has 2 significant digits, the 2 and the 7, and the 0 is not significant. And lastly, if it's at the left end of a decimal, so for example 0.02, these are on the left end of this decimal, so they are insignificant. Right? They are not significant digits, just the 2 here is significant. So this number has 1 significant digit, this has 2, this has 3, 2, and 3. Okay, and then again, all of our non-zero digits, 1, 2, 3, 4, all the way up through 9, are significant digits. So now let's take a look at the definitions for precision and accuracy. So the precision of a measurement is indicated by the place value of its rightmost significant digit. So 270, this is precise to the 10th place, because that is its rightmost significant digit. If that same number has the overbar, right now this is precise to the ones place. Okay, so again, precision is looking at the rightmost significant digit, so it is precise to that place value. 208,790, right? Again, this is precise to the 10th place. If I were to make this a decimal, now it is precise to the 10th place. Accuracy refers to the number of significant digits that the number contains. So for example, 308 is accurate to 3 significant digits, or the number 180 is accurate to 2 significant digits, whereas 4 is accurate to 1 significant digit. So accuracy refers to the number of significant digits, whereas precision again refers to the rightmost significant digits. For these same numbers, this 4 is precise to the ones place, 180 is precise to the tens place, and 308 is precise to the ones place. We are concerned with precision and accuracy in our calculations. So for example, whenever I add and subtract, I'm concerned with how precise my measurements are. That is, I'm concerned with the rightmost significant digits when I add and subtract. When I multiply or divide, I'm concerned with the accuracy of my measurements and my answer. So when I multiply or divide, I want my measurements to be accurate. Let's take a look then at precision as it refers to addition and subtraction. If I am adding three numbers, let's say 4.1 seconds plus 3.5 seconds plus 1.27 seconds, add those all up. When I add, keep in mind when I'm adding decimals, I line up my decimal point and then add like place values. So here, zeros and a 7. 1, 5, 2, I get 8, my decimal point, and then another 8. So my answer here is 8.87 seconds. Well, precision comes into this because I can only be as precise as my least precise measurement in adding. So both of these are precise to the tenths place, where this was precise to the hundredths place, which means my answer then can only be precise to the tenths place, so I have to round my answer now to the tenths place. I look then at the number to the right, it tells me to round up, so I have 8.9 seconds as my final answer. The same goes for subtraction. If I have 7.425 and I am subtracting from it 3.5, my answer then will have to be only as precise as my least precise number here to the tenths place. In order to subtract, though, I need to fill in zeros here for those place values and subtract. So I have 5, 2, borrow from the 7, 9, 3, and bring down my decimal point. Again, that 3.5 was only precise to the tenths place, so I have to round my answer to the tenths place. This then is 3.9 as my final answer. This then is the standard practice when dealing with measurements. So if these were inches, right, the standard practice would be to have my answer only as precise as my least precise measurement. So we do not always do this with decimals, only when we are concerned with precision as far as our measurements go. Next, we'll take a look at accuracy in regards to multiplication and division. When we are multiplying, there are two things we need to be aware of. So if we have 3 feet times 2 feet, and what we are concerned with is multiplying the numbers of these measurements as well as the units of these measurements. So to get started, I have 3 times 2, that gives me 6, and I also have feet times feet, which gives me feet squared. I have 3 feet times 2 feet, multiply my numbers and multiply my units. Again, I'm concerned with accuracy. Right? If both of these numbers are accurate to one significant digit, then my answer can only have one significant digit. Just as in precision, right? In accuracy, my measurement can only be as accurate as my least accurate measurement in my multiplication or division problem. Next, let's do 2 inches times 3 inches times 5 inches. So if I multiply all of this together, again I'm multiplying my numbers together, 2 times 3 times 5, I get 30. Inches times inches times inches, I get inches cubed, or inches to the 3rd power. Again, each of these are only accurate to one significant digit, so my answer can only be accurate to one significant digit. I check it, and indeed this is accurate to one significant digit, since zeros at the right end of a whole number are not significant. If we are dividing, let's say 30 miles divided by 2 hours. First we'll focus on just the numbers, 30 divided by 2. So 2 goes into 3 once, bring down our 2, we have 1 left over and bring down our 0. 2 goes into 10 5 times, 5 times 2 is 10, and we have no remainder. Our units, we had miles divided by hours, which is the same as miles per hour. So our answer here is 15 miles per hour. But again, our answer can only be as accurate as our least accurate measurement. Here, this is accurate with one significant digit. 30 again has one significant digit. So our answer can only have one significant digit, which means I need to round this to where it has one significant digit. So I need to round to the tens place here. I look at the 5, it tells me to round up. So my answer then is 20 miles per hour. So now my answer is just as accurate as the measurements I took going into the problem. So switching gears a little bit, one useful thing with measurements is to take a decimal measurement, say 0.462 inches, and find the nearest equivalent of a 32nd of an inch. So to do this, we can take our decimal 0.462 and multiply it by 32 over 32. Again, this fraction here is equivalent to 1, so we're not changing the value of anything here, but when we multiply, we can put our decimal over 1 here to make our multiplication a little easier. 0.462 times 32 is 14.784, and that will be over 32. So if we want to find the nearest 32nd of an inch, right, we round our numerator now to the nearest ones place. It tells me to round up, so I have 15 32nds. So that tells me now that 0.462 is closest to 15 32nds of an inch. You can also do this with 64ths, 16ths, 8ths, 4ths, right? Whatever you want to do. Again, just take that decimal number, multiply it by what you want over itself. So here we wanted 32nds of an inch, 32 over 32. Do the same with any other number. We can find the nearest fractional measurement for that decimal. Now we've been using units of measurement in our calculations up until this point, but let's take a closer look at the English and metric units of measurement for length, weight, and volume. Our English measurements for length are inches, feet, yards, and miles, where 1 foot is equal to 12 inches, 1 yard is 3 feet, and 1 mile is 5,280 feet. The English measurements for weight are ounces, pounds, and tons, where 1 pound is 16 ounces, and 1 ton is 2,000 pounds. And finally, the English measurements for volume are cup, pint, quart, and gallon, where 1 pint is 2 cups, 1 quart is 2 pints, and 1 gallon is 4 quarts. We can convert between units within their specific measurements. So length units I can convert from yards to inches, from feet to miles. Weight I can convert from pounds to tons. Volume I can convert pints into gallons. But I cannot convert between units. I cannot convert 2 cups into pounds. I cannot convert 1 quart into yards. So let's take a closer look at converting units within their type of measurement. So if I want to convert, say, 2 feet into inches, every time I am converting English units, the method I will use is multiplying by a ratio. So 2 feet, I'm going to multiply this by a ratio that compares feet and inches, the unit that I have and the unit that I want. Every time that I set up my ratio, I'm going to take the unit that I have and put it in the bottom of my ratio, and the unit that I want in the top of my ratio, and then fill in the appropriate numbers. For example, there are 12 inches in 1 foot. I have now set up my ratio, and now I can multiply the 2 feet that I have by that ratio of 12 inches to 1 foot and get the answer that I want. I put my measurement over 1 and multiply. 2 times 12 gives me 24. 1 times 1 is 1, so I don't need my denominator there because it's just 1. My units then, here feet cancels out, and I'm just left with units of inches. So 2 feet is the same as 24 inches. Again, I'm doing this every time I'm converting units. Say now instead I have 32 ounces and I want to convert this into pounds. Again, I multiply by that ratio, what I have on bottom, what I want on top, and then fill in the appropriate numbers. 1 pound is 16 ounces. So I multiply again. Here I get 32 over 16. The units of ounces cancels out and I'm left with units of pounds. I now need to reduce my fraction. 32 over 16 is 2 pounds. So 32 ounces is 2 pounds. Units of area can be a little trickier. For example, square feet and square inches. However, I'm going to give you a conversion chart with units of area and cubic units so that you don't have to worry about this. So for example, 1 foot squared is equal to 144 inches squared. That's because a square foot, if I have 1 foot on each side here, that's the same as 12 inches along each side. And if I find the area of this, it's 12 times 12, 144 square inches. So if I'm converting, say, 2.5 feet squared into square inches, I do the same thing again, set up that ratio with what I have on bottom, feet squared, what I want on top, inches squared, and then fill in my numbers. 144 square inches is the same as 1 foot squared, and I multiply. So here, again, put that over 1. 2.5 times 144 is equal to 360. My units of feet squared cancel out, and I'm just left with my inches squared units. One unit of measurement we haven't talked about is time. Again, that breaks down into seconds, minutes, hours, and days, and months and years, but we're not going to talk about those. So we see here 1 minute is 60 seconds, an hour is 60 minutes, or 3,600 seconds, and 1 day is 24 hours. So if we want to convert with time, say for example I want to know how many seconds are in 2.5 minutes. Again, I do the same thing as I was doing before, multiply by that ratio, put what I have on bottom, what I want on top, and then fill in the numbers from this comparison. 60 seconds is 1 minute. I multiply. 2.5 times 60 is 150, and our minutes cancels out, leaving us with units of seconds. When it comes to our metric units of measurement, we can use an anagram to help us remember how to convert. So for King Henry doesn't usually drink chocolate milk, can help us remember the order of the sizes of our units. Our units for length, weight, and volume will be meter, gram, and liter, respectively. So what we see here is we have on the high side kilometers, hectometers, decameters, our meter, decimeters, centimeters, and millimeters. Or if you replace that with gram, kilogram, hectogram, decagram, our gram, decigram, centigram, milligram. You can do the same thing then with liters, hectoliters, deciliters, liters, so on and so forth. Their abbreviations are as follows: Kilo is a K, hecto is an H, so on and so forth. Our units, meters is an M, grams is a G, liters is an L. So if I have meters, I just have my M. But if I have decameters, that's D-A-M. If I have centigrams, that's C-G. If I have milliliters, that's an M-L. So anytime I'm creating my unit of measurement, I take my prefix and then follow it up with the unit that I'm working with. Say, for example, I have 230 centimeters, and I want to convert this into decameters. Well, if I'm here at centimeters, I'm going 1, 2, 3 places to the left. So I'm going to do the same thing with my number here, 1, 2, 3 places to the left with my decimal point. My decimal point goes there, and I have 0.23 decameters. Let's say now I want to convert 3.02 kilograms into centigrams. So I start at my kilo, go 1, 2, 3, 4, 5 down to my centa. So I'm moving my decimal place now 5 places to the right in the same direction that I moved along this chart. So that 3.02 becomes 1, 2, 3, 4, 5. Those extra spaces I fill in with zeros, and I have 302,000 centigrams. This is all there is to converting with the metric system. It's just going to be moving your decimal point to either to the left or to the right, depending on which direction you're moving along this chart. One last thing about metric conversions. We have here that 1 cubic centimeter is equal to 1 milliliter. This also means that 1 liter then is 1,000 cubic centimeters. So we can convert from these two units. So say I had 200 cubic centimeters, and I want to convert this now into liters. I can multiply this, right, again by that ratio, centimeters cubed on bottom, my liters on top, 1 liter to 1,000 cubic centimeters. I multiply these together, and I get 0.2 with my new unit of liters. Next, we'll take a look at metric to English conversions. We have our length conversions, so inches to centimeters, feet to centimeters, yards to meters, and miles to kilometers. Our weight conversions, so ounce to gram, pounds to kilograms, and tons to kilograms. And volume, cubic inches to cubic centimeters, cubic yards to cubic meters, fluid ounces to cubic centimeters, quarts to liters, and gallons to liters. We will treat these the same as we do English to English conversions. We have our comparisons here, inches to centimeters. We'll set up our ratios using these, and then we can use those ratios to convert from one unit to another. So if I weigh 180 pounds and I want to convert this into kilograms, I'm going to multiply by the ratio. My pounds goes on bottom, kilograms on top, and then I fill in the numbers for each according to that ratio. I know that 1 pound is equal to 0.4536 kilograms. So 180 times 0.4536 is equal to 81.648. My units of pounds cancel out, and I'm left with units of kilograms. And just as a refresher, if I want to make sure that my answer is accurate, I check here. My least accurate measurement here is my 180. It has 2 significant digits. So my answer should only have 2 significant digits, which means I will round here to the ones place. Check the 6, tells me to round to 82 kilograms. We'll do this same method for other English to metric conversions, just like we did with the English to English conversions. Lastly, let's take a look at converting temperatures. When converting temperature, we can use this table or this thermometer to compare measurements of Fahrenheit and Celsius. So if I say, what is 5 degrees Fahrenheit, I see that it is right next to the negative 15 degrees Celsius. Or if I ask myself 25 degrees Celsius, well, that's right here, which looks to be 77 degrees Fahrenheit. There are more algebraic ways to convert between Fahrenheit and Celsius using a formula, but we're not going to cover that in this section. But you should be aware of it, and we will cover it later in the course. For now, though, I will give you a copy of this table so that we can convert between Fahrenheit and Celsius. So if I say 60 degrees Celsius, go ahead and find that on the chart. Good, you found it. It's the same as 140 degrees Fahrenheit. We'll do one more. Go ahead and find negative 22 degrees Fahrenheit and convert that to Celsius. Okay, good. I come down here to negative 22 on the Fahrenheit scale. Look across, and it is negative 30 degrees Celsius. That will cover it for Chapter 5. Make sure you print off your homework and bring it into class. Also, don't forget to take notes on this and to bring any questions you have to class. I will see you later.